Okay, you have made it this far. This is the last section we're talking about with graphing. Doesn't mean your graphing goes away. Just means this is the last one we're going to talk about in this chapter. Parallel and perpendicular lines. You need to understand that parallel lines have the same slope. That doesn't look like an M. It's supposed to be an M. They have the same slope. That's an M. And that perpendicular lines have negative reciprocal slopes. Negative means that they are opposite signs. And reciprocal means that they are flipped fractions. Let's look at a couple of examples. So down here, they don't look quite parallel, but these are parallel lines. Parallel lines have the exact same slope. And you can see that they have the same slope because in this problem up here in this equation, you can see clearly that m is equal to 1/2. And in this equation, you can see clearly that m is equal to 1/2. And 1/2 and 1/2 are the exact same number. That means they have the exact same slope. Doesn't matter what they look like. If they give you this information, they have to be parallel lines. Now, I am a geometry teacher at heart. So when I talk about parallel lines, I usually use the symbol for parallel. And the symbol for parallel looks like that. Looks like an 11, only it's a little bit longer than an 11. Over here, however, these are all perpendicular lines. We'll first talk about the orange ones. These are perpendicular lines. I gave the equations for these. The equation up here says that my slope is equal to 1/1. The equation down here says that my slope is equal to -1/1. They have opposite signs. One's positive, one's negative, and my fractions are flipped over. They happen to be the same too, but they are flipped over. Now you cannot call these, just because they were the same number, you cannot call them parallel lines. Obviously they don't look parallel. However, you have to call them perpendicular because one of them is positive and one of them is negative, and the fractions are flipped. Both of those things have to be the case in order for them to be considered perpendicular. Now the definition of perpendicular lines says that they meet at a 90-degree angle. That part I think you already knew. But just because they look like they're at a 90-degree angle is not proof. In algebra, you have to give proof that they're at a 90-degree angle, and you do that by showing that the slopes are negative reciprocal slopes. For the other one, the one I'm going to do in pink, it's a little bit easier to see because you can tell up here the slope for this is 2/1 and the slope for this one is -1/2. One's positive, one's negative, so they have opposite signs, and one of them flipped over gives you the other one, so they have flipped fractions. That means they are negative reciprocal slopes. That means they must be perpendicular. Now, remember I told you I'm a geometry teacher at heart. That's the symbol for parallel. What's the symbol for perpendicular? Do you remember? It's the upside down T. That's the symbol for perpendicular. So I tend to use my symbols more than I write them out, because who wants to spell parallel and perpendicular every time you talk about them? Just saying, it's a lot of work. So in other words, the only way to tell if some equations are parallel or perpendicular is to look at the slopes. Well, that's pretty simple because we know how to find slope. We got 3 different ways of finding slope. So if we look at a picture, we can find the slope. If we look at points, we can find a slope. Or if we look at equations, we can find a slope. So all we have to do is make sure the slopes are good. So when I look at A, I can say that the slope for the top one is 3 because it's already in slope-intercept form. And when I look at the second one, I can say the slope for that one is 3. Well, they're the exact same number, so these two must be parallel. When I look at the next ones, I can see that the slope for the first one is 1/2, and the slope for the second one is -2/1. They are reciprocals of each other. One's positive, one's negative, so that one must be perpendicular. This one isn't quite so simple. We're going to have to do some work before we can figure out the slope for this one. So let's do some work. So we have 4x plus 6y is equal to 5. I need to get the 6 by itself so that we can have it in slope-intercept form so that we can find our slope to begin with. So I'm going to subtract 4x from both sides. 6y equals -4x plus 5. Divide everything by 6. And get y is equal to -2/3 because I want to reduce this one. X plus some number, I don't really care what it is because all I care about is the slope. Since all I care about is the slope, I'm going to go ahead and write it. M equals -2/3. That's for the first one. For the second one, 8x plus 12y is equal to 9. Gotta get the y by itself. Divide everything by 12. Y is equal to, that reduces down to -2/3. X plus some number, I don't care what that is. All I care about is the slope. M equals -2/3. Since these two are exactly the same, that means these must be parallel lines. D. They say y equals 1 and x is equal to -2. Well, that's great. That didn't help me with the slope, though. You have to remember your clouds for this one. When y equals 1, what kind of slope does that have? Well, that has a horizontal slope. 0 slope. It's a horizontal picture. When x is equal to 2, that has a vertical slope. Horizontal lines and vertical lines, they are perpendicular. For E, you have to put them in slope-intercept form first. I'm going to let you try E, then we'll talk about it. Okay. So for the first one, subtract 2x from both sides. Y equals -2x plus 4. So my slope is -2. For the second one, 2x minus y equals -4. I subtract 2x from both sides. -y is equal to -2x minus 4. Divide everything by -1 so I can get the y by itself. Y equals 2x plus 4. My slope is 2. Are they parallel, perpendicular, or neither? Well, they can't be parallel because they're not the exact same number. This one's -2 and that one's +2. That's not the same. There's a big difference. There's a $4 difference between owing somebody $2 and having $2. So they're not the same number. So they can't be parallel. Are they perpendicular? Well, one of them is negative and the other one is positive. So they do have opposite signs. But this is -2/1 and this one is a +2/1. It's not a 1/2. They didn't flip it over. Since they didn't flip it over, it can't be perpendicular either, which means this one must be neither. It's not parallel or perpendicular. Now, all that's fun, good, wonderful, easy stuff. Nice. Give me some homework. Let me go. But no. We have to talk about what all this stuff has in common. So we got to tie everything together. The whole entire section can be summed up in these few problems. Scary, isn't it? So, I'm going to angle this some so it's easier for me to write on. So when we talk about the first one, they want the line passing through this point, but they want it to be parallel to this line. Well, we talked about what you need in order to write the equation of a line. You need not slope-intercept or standard. You need it to have point and a slope, or 2 points. I don't have either of those. I have 1 point, but I don't have a slope. So I need to figure out what my slope is going to be. Well, they would say they want it to be parallel to this. So if they want it to be parallel to this, we just learned that parallel lines have the same slope. So we could figure out what the slope to this one is, and then we know the slope for this one. So I'm going to figure out the slope here. So we know 2x plus y is equal to 5. So I can subtract 2x from both sides and get y is equal to -2x plus 5, which means the slope of this line is -2. Well, that's good to know, because that means that my parallel slope, which is the one that we need, is going to be -2. So now I have a slope and I have a point. Now that I have a slope and a point, I can put it in my point-slope form. y1 is -3. M, we said, was -2. x1 is 2. So that's going to make it y plus 3 is equal to -2x plus 4. Now, they say they want my answer in slope-intercept form and they want it in standard form. So I got to have 2 answers. I don't have either one right now, but I know if I get my y by itself, by subtracting the 3, that would give me y equals -2x plus 1. And that is in slope-intercept form. If I want to put it in standard form, I could go from y equals -2x plus 1 and add 2x to both sides, and that way it'll be all pretty with the 2x and the y being on the same side. And that is my standard form. For the next one, they want it passing through this point, and perpendicular to that equation. So just like before, we have to figure out what the slope of this is, so I can figure out what the perpendicular slope is to put it with that. So here my slope is negative 2 over 3. But that's not the slope that I want. I need the perpendicular slope. So my perpendicular slope has to be opposite. So instead of it being negative 2 over 3, that means it's going to be a positive. And instead of it being 2 over 3, it has to be a reciprocal. So that's going to be 3 over 2. Now I have a perpendicular slope and a point. So I can use my point slope form. y1 is negative 4. And we said was 3 over 2. So that's going to be what? Plus 4 is equal to 3 over 2x minus 3 times 3 is 9 over 2. I don't like fractions, so I'm going to multiply everything by 2. 2y plus 8 is equal to 3x minus 9. Now, I take my 2y plus 8 equals 3x minus 9. They want it in slope-intercept form, so I have to subtract 8 from both sides. That gives me 2y equals 3x minus 17. Divide everything by 2. I get y equals 3 over 2x minus 17 over 2. That's good. But in order to get my standard form, I don't want to start right here because I got all those fractions in it again, and we know we can't have fractions in standard form. So I'm going to go back and I'm going to start back from right here when I didn't have those fractions in it. So I'm going to pull this whole line by itself and put it in standard form. In standard form, you remember the x and the y have to be on the same side, and the numbers have to be on the other side. So I can subtract 8 still. But I'm going to go ahead and subtract the 3x too. Take care of both of them at the same time. So that's negative 3x plus 2y is equal to negative 17. Now, is this in standard form? No, because we got the negative in front of the 3x. We can't have that. So I have to go through and change all my signs. So that'll be a positive 3x minus 2y equals a positive 17. That's my standard form. Looks pretty. That does not. Very useful. That is not. Problem number 3. They want it passing through this and parallel to that. So in order for us to figure out what it's parallel to, we're going to have to find the slope of this first. So minus 6x minus 6x divide everything by 3. We don't care what that is, we care about this. So here my slope is negative 2, which means my parallel slope is also going to be negative 2 because they have to be the same. So those are the two things I'm going to use. Sorry. Y minus y1 is equal to m times x minus x1. y1 is 1. M we said was negative 2. X minus 5. Negative 2x plus 10. Add 1 to both sides. Y is equal to negative 2x plus 11. That's my slope-intercept. Now I have to find my standard. Since there is no fraction here, I can just go ahead and move that 2x over and get 2x plus y is equal to 11. But when there's a fraction, make sure you go back and pick something that doesn't have fractions in it to go from for your standard. One more, and then this whole chapter will be toast. Won't that be nice? Not just this whole chapter, but this chapter is the last chapter you have before Christmas. So once you finish this chapter, you take that test. You got to do the homework tonight, but you take that test, and once you finish the test, then all you have is that midterm, and after the midterm, you are done until January. That's like almost a whole month you have free with no math. Won't that be great? I'm just saying it's because you got me. Oh my goodness. Okay, so here we need to figure out what our slope is. So I'm going to subtract 3x from both sides. Negative 2y is equal to negative 3x plus 5. Negative 2, oh sorry, divide everything by negative 2. Y is equal to a positive 3 over 2x plus some number. I don't care what the number is because all I care about is my slope. So here my slope is 3 over 2. But we don't want 3 over 2. We want the perpendicular slope. So if this is positive, this one has to be negative. If this is 3 over 2, this one has to be flipped over, so it's got to be 2 over 3. Now I have a slope I can use and a point I can use. y1 is 3 equals negative 2 over 3 times x minus negative 2. Make sure you change that to a plus. Negative 2 over 3x, and then negative 2 over 3 times a positive 2 is going to give you a negative 4 over 3. We don't want fractions, so multiply everything by 3. 3y minus 9 is equal to negative 2x minus 4. I need to move my 9 to the other side. That gives me 3y is equal to negative 2x plus 5. Divide everything by 3. And you get y is equal to negative 2 over 3x plus 5 over 3. Useful, not pretty. Oh, Kate, hold on. Then I'm going to go back up here to where I was and pick back up from here because I don't want all that fraction stuff in it. So I still want to add 9 to both sides, but while I'm doing that I'm going to go ahead and add my 2x too. So on this side I have 2x plus 3y. And on this side I have my 5. And that's my standard form. So, time for homework. Aren't you just tickled pink about the homework? Okay, probably not, but I'm going to give you some anyway. On page, I'm going to write it right here. Page 394. Numbers 25, 27, and 47. And then on page 399, numbers 19, 21, and 33. Now, what to do for a review? Well, you needed to practice the graphing a line, so you had that worksheet for that. There will probably be a review in your packet that I send to your mom for your chapter. If not, call me and I'll tell you what to do for a review. But I'm pretty sure I'm going to put one in your packet so that you can get some practice before you take the test, because this is a hard chapter. There's a lot of stuff in it and it's all new. So I really need you to make sure you do all your homework, you do it on time. Go ahead and actually spend time reading through all the notes before you work on your chapter review and before you take your test. Again, read through all the notes. Make sure you write down on index cards or something the formulas that I told you to memorize, all the ones that I've highlighted over the days, the formula for slope and the formula for slope-intercept form, and for point slope form and for standard form. Make sure you know all those. Make sure you know what parallel and perpendicular slopes look like. Make sure you know how to graph a line and how to find intercepts. All that stuff is important, not just plotting points or the XYT chart. You got to be able to do everything. And I will talk to you later. Love you.